Meet Jim. Jim is a world-class researcher working on breakthrough scientific commercial research. What is he working on? Well, he's developing flexible solar cells. He's developing flexible transparent displays. He's working on smart skin technologies, and he's pushing forward technologies in quantum computing. And you may be wondering, how could he possibly be doing all of this at once? Well, that's because Jim is working with fullerenes. These Nobel Prize-winning carbon nanomaterials are 1/100,000th the width of a human hair, and they're at the heart of all of these applications. However, there's one major drawback with fullerenes, and that's the high cost associated with them. This not only makes the R&D prohibitively expensive, but also prohibits the competition on the free market of these products. When fullerenes are made, they appear as this black soot, and this soot is very cheap, but it must be purified first before it can be used in these applications. This brings up the cost to hundreds of dollars per gram, all the way up to hundreds of millions of dollars per gram, which is prohibitively expensive. So the main problem here is the machine that is used to purify these materials. It costs over $150,000 upfront and can only purify milligrams of these fullerenes at a time. So what we want to do is replace this machine with something that's more commonly used by chemists all around the world, these glass columns. These are very cheap, and they're used to purify a plethora of different chemicals on a large scale. But the problem is they conventionally cannot be used to purify fullerenes. And so this is what led us to develop our own proprietary solution, this powder. This powder is capable of doing the separation on a large scale. And the way this works is we take these cheap columns and we put our powder inside. Then we push the black soot through our powder, and we get pure fullerenes coming out the other side. Now, we take those pure fullerenes and we sell those to the researchers. And because the consumer never interfaces directly with our proprietary technology, we intend to protect our IP by operating under a trade secret. So instead of going to our competitors to get a small quantity of these expensive fullerenes, the consumers can come to us to get a large quantity of affordable fullerenes that our competitors cannot match. Our motivation for this is the $2.5 billion market value of fullerenes and their research that we hope to tap into using our proprietary technology. Back in January, we developed our first working prototype, and earlier this month, we had completed some preliminary customer validation. We need the $5,000 now to be able to continue our R&D in order to bring down our cost of goods sold so that we can start to stockpile our product in order to make sales by the end of summer. I'm a PhD candidate in chemistry, and my co-founder is a professor of chemistry. And together, we were the perfect team to come up with this type of technology because we are worldwide leaders in this niche of nanotechnology and organic chemistry. Our overall goal is to be able to take these fullerene products, lower their costs so that researchers can develop these new technologies for consumers to use in their daily lives, like you. We are Quantum NanoPure, and we're developing products that are enabling the next generation of technology. Thank you.